So the single AP, they might able to support the dual band. That means they not only can provided the 2.4 frequency band, okay, they also can giving the 5 gigahertz frequency band to the access user. So right here, you can see it got so many access users trying to connect to the 2.4. Okay, this is by default what they're going to set, and it's only one PC is actually, connected to the 5 gigahertz frequency band. So this is a problem over here. So they have so many PC, right? They actually can able to connect to 5 gigahertz, but none of them is connect. Okay, there's only one. So the load balancing, right, is not only happening to the overlapping area when they have a two AP provide the same SID. It also can use for the two different frequency band to achieve the load balance. So here, they going to do some detection. The AP received the probe request on the 2.4 and another is on the 5 GHz. So I'm going to start from the top here. Okay, right now my AP, okay, imagine right now this AP received the 2.4. So I'm going to check. Okay, right now they send me the probe request is belong to the 2.4 frequency band. Is there I still continue to receive a same 2.4 radio from the peering equipment? If yes, then I can further prove right. This device they only can, or maybe this PC can only support the 2.4 because when the PC want to connect to the network, the first thing they need to do is send a probe request to the AP. Okay, so when they keep sending the request is using 2.4, then the AP itself will automatically know, oh, right now this PC only can use 2.4. But when there's no, okay, first time they send 2.4 probe request, second time they send 5 frequency band the probe request, they will know, oh, okay, this means right now this PC right, can support both. Okay, so this one will be sent to the other way around. Okay, first time I receive 5 gig radio. Okay, is that I still continue to receive a same 5 gig radio? If yes, that means the SDA only can support 5 gig frequency band. Okay, this is the reason for it. Okay, so this is a load balancing between the 2.4 and 5G frequency band. Okay, now SDA requires to associate with the AP. So does the number of the access user on the AP exceed the start threshold? When it's no, so the SDA preferentially connected to the 5G radio. If yes, then they'll start to perform the load balance here. So below here will be the load balance algorithm. So as you can see, they're using a number of the 5 gig and also the 2.4. Okay, divided by the number of access user on the 5G radio. Okay, so this is the algorithm. Okay, the next one is a configure band, the sharing. So ensure that AP support both 5 gigahertz frequency band and also 2.4. And also they're using the same SSID, then you can able to perform the loop balance. There's no point for you to using the two different SSID then to perform the loop balance because the loop balance only when they're actually using the same SSID, same security policy, okay, but with the different frequency band. Yes, they allow you to do that. So this is how they actually are going to create that. For we'll go into the VAP profile and then go there using undo command to enable it. Because by default, the band still actually is disabled. So we need to use the command undo to enable it. Then the next one. Okay, we need to go to the IRM profile and configure the parameter here if you want. So the band still balance start threshold 20. Okay, so that's what's the limit for the threshold. You can able to configure the number, the value over here. Okay, content number 5, the user CSE. Okay, stand for the common access card. So user CSE overview. The user CAC function allow an AP to control the user access based on the threshold specified according to the radio channel usage, the number of the online SDA, or maybe the terminal SNR. So there's a two different threshold over here. So they have a threshold for the access of the new user and another one is for the roaming user. So here they have a new user request to connect to the AP. Okay, right now our AP has already received the new request. So they're going to check, is the CAC threshold reached to the AP or not? So right now I receive a new request. So this is a new user. I want to check, right, whether I already receive, I already access to the limit of all the user. If yes, that means I'm going to deny the user. I'm going to tell him, sorry, I can't able to provide the connection right now. Okay, because I already access to the limit. Okay, and same to the roaming user, they do the same thing. So when it doesn't receive to the threshold, okay, then you let the user to connect and associate with the AP. So for the CAC can be implemented into the following way. So the first way is based on the channel usage. So I can base on the channel, so and start to doing the CAC. Or I can actually base on the number of the user. Okay, I'm going to check all the traffic. When the user reach to the threshold that I set, then you'll start to using the CLC to deny the client. And I also can base on the terminal SNR. This means I will using the signal strength to detect. As long as the SS user, the dBm is smaller to the certain value, I'm going to reject the connection from this client. Okay, so we can able to base on the channel number and the terminal SNR. So this is the way how we configure that. So Sam, we can enable this command from our RRM profile. So this time we're not going to do the undo anymore. So we're just using the command UAC client number enable. But right now I want to base on the number and start the CAC. Okay. If you want to using the channel, then you can using the channel utilization, okay, and set the threshold. So we need to do the enable here, or else after even you already configure the channel utilization threshold, this one we're going to take the effect until you're going to enable this. Okay, number 6, smooth channel switching. Okay, the AP and the SDA switch channels, okay, simultaneously ensuring the uninterrupted service. Okay, why they want to do this one? Actually, for this one, they actually related to the previous one, what we learned previously, okay, the calibration. Because when the radio calibration is already enabled, and when they detect they have so many interference to the current channel, as example right now I'm using a channel number 1, and suddenly they have so many APs go online, and my AP detect they have the interference on the surrounding, so the AP have to force to change the channel to number 6. So when change to number 6, suddenly it will cause the STA lost the connection. So that's why the smooth channel switching is very important. They want to able to swap the channel into the different one, and also need to guarantee the client they never get interrupt. So this is one of the technology over here, the smooth channel switching. So this is the way how we're going to do that. So this time we're not going to RRM anymore. We're using the radio 2G profile. Okay, go into the profile there. Okay, using the command undo channel switch announce disable. Okay, by default is disabled. Okay, after we're going to enable this, right, that means the channel switch announce, right, we're going to send from the AP. Because why the client we're going to lose the connection with the AP? Because when the AP swap the channel, suddenly the client they didn't know anything. They still keep sending the same prop request, like example channel number 1 to the AP. But right now, the Huawei SID from channel 1 is already changed to the channel number 6. So when they have a channel mismatch in between the AP and the SCA, they're not able to allow the SCA to continue associate with the current AP. So they will lose the connection. So To enable the channel switch announcement is very important. So before the AP sort the channel from 1 to 6, you're going to send the switch announce message to the client and inform to the SDA. Right now, SDA, the few seconds later, I'm going to change the channel. So you also have to follow me and change your prop request channel to the channel 6. Okay, so this is the meaning over here. What we need to do the undo channel switch announce. Okay, so here will be the last one that I want to cover today. Automatic per packet power adjustment. Okay, so this is the function over here to reduce the AP power consumption and interference to the surrounding device. So this is the main function. So the AP can able to detect the signal strength in the real time. So when the AP detect the signal strength of the SDA is strong, okay, the AP reduce its own transmit power when sending the packet. Okay, if the AP detect the signal strength of the SDA is weak, the AP recover the normal transmit power to send the signal. So they can able to perform this one. Okay, not only can save your power, and they also can do the auto adjustment. So the AP going to check if right now, okay, I detect my current SDA1 and SDA2, they have a very low the signal strength. When they want to send me the prop request, right, I notice the SDA1 and 2, they can't able to give the very strong signal. So to increase the performance between the SDA and so the AP. So the AP have to adjust its own power level when they connect to the SDA1 and SDA2. Okay. Oh, sorry. This is happening to the SDA3 because they have a weak, because it's too far away. When the two close already, they actually have to reduce the power strength. Okay. Yeah. So this one actually is reduced and the other side is increased. Okay. So the next one, how to enable that? Okay. So for this kind of adjustment, we need to do it on the radio 2G profile. Okay, this one is for the 2.4. Of course, if you want to do for the 5 gigahertz, so you just go to the radio 5G profile there and enable that. Okay, so the way to enable is very simple. We just use power auto adjust enable. Okay, so this is all the content that I already cover on this topic. So they include the introduction to the WLAN radio management, okay, radio calibration, of course the load balance, band steering, the user CSE, smooth channel switching, and also the last topic that I covered just now. Okay, thanks for everyone to listen the training today. Okay, and my name is Roy. Thanks for your attending the training HCNP WLAN. Okay, and hope to see you again.